Welcome back. This is the second lesson recording for IM1, September 11th, 2020. So where we've left was we've talked about the drone simulation, and we've talked about the graph and how to interpret the graph and figure out what was the input, what was the output at different times, and using the function notation. So now we're going to be talking about this graph being increasing or decreasing. So when we're talking about a graph increasing or decreasing, we're really describing how the output changes as the input increases. So let's put that sentence apart. So what is output? Output is the y value, right? How does the y value change as the input? What's input? That's the x value, okay? Input increases. That means really we're talking about the input is increasing as we're going from 0, 1, 2, 3, 4 going to the right? That the input is increasing. So we're asking, as the graph is increasing, as the input is increasing going from left to right, how does the y value output change? So the behavior of graph from left to right is what we are really talking about. And we can say that the graph is increasing here. See, the y value is starting from 0 going all the way up to 4. Okay, it's increasing over here. The function increases in that interval from 0 to 2, and then from 2 seconds to 5 seconds the function is constant because it's not going up or it's going down, it's constant. And then finally the function is decreasing at this interval from 5 seconds to 7 seconds. Okay, so I would like you to pause the video and take notes right here. Okay, I'm assuming that you have done that. So again, it's really, we're just talking about the slope, aren't we? Okay, we're talking about, is the slope increasing? Is the slope positive, I should say? And then slope is 0 here, and then slope is negative. So when the slope is positive, it's increasing. When the slope is 0, it's just constant. When the slope is negative, it's decreasing. It's easier when the graph is of linear function, okay? But we are going to deal with nonlinear functions too. All right, so looking at this, what do you think? Is this increasing or decreasing? Is this function increasing or decreasing? As we go from left to right, the y value is going from -4 all the way to +2. So it's increasing, going from -4 to +2. So it's increasing, and we would mark it with an arrow looking like this. Okay, so this function is always increasing. Okay, what about this function? Okay, again, like I said, we're really talking about, is the y value increasing or is it decreasing, so on. Okay, so y value going from left to right, we always interpret from left to right. From here all the way to this point right here, the graph is increasing because the y value is increasing. And then the y value is decreasing from a little over 2 to maybe 1.5. So it's decreasing here, and then it changes again to increase again from this interval to that. Okay, so we can say until when the x was -0.3, the function was increasing. When x, the input, was between -0.3 to 1.5, the function was decreasing. So we describe in terms of the x value, or the interval for the x value. And then from this point, when x was positive 1.5 to infinity, the function is increasing. Okay, all right, so we're going to check your understanding about increasing and decreasing. You are going to do the Desmos cards from 4 to 6 right now. please do that. Pause the video and go ahead and do that. Okay, now finally we're going to be talking about domain and range. What is domain? What is range? You are going to be taking notes. So can you start by writing down, copying down this graph? Okay, so you're just going to draw some function that looks like this. Again, functions can be curved or straight line. We call this non-linear because it's not linear, as in it's not a straight line. Okay, so this case, we say this is the domain and this is the range. What does domain and range mean? Domain is all possible input values in most simple terms. Okay, all possible input values that we have of the graph. Okay, so the graph, how far does the graph extend? It starts here and it ends here. It does not go on forever. Okay, if it does go on forever, there will be these arrows extending both directions, but there is not. That means we need to assume that it starts here and it ends there. So domain is all possible input values. So we're really talking about the x values going from here to there. Okay, so little over 1 all the way to little maybe 4.5. Okay, what is range? Range is all possible output value. So we're really talking about how far does the graph extend on the y-axis. So for domain, how far does the graph extend on the x-axis? When do we have values on the x-axis? How far does it extend on the y-axis? Okay, so we can say the domain extends from 1.1 to 4.5. So we can say that all domain is that all values between 1.1 and 4.5, because that's how when the graph starts at 1.1 and it ends at 4.5. We do not have graph beyond that. We do not have graph before that. That means there are no x values. There are no input values possible. Okay, what about range? Well, we can start looking at the graph and we can say, oh yeah, it starts at 1.1 here too for the range, and then it goes to 3.2. Okay, so then we're really talking about the how far the graph extends on the y-axis for range. So it's going to be all y values between 1.1 and 3.2. And oftentimes students get mixed up as to which is domain, which is range. So one thing that you can remember is my two friends Docs and Ray. Just remember Docs and Ray. Docs says domain is really all possible input values or all possible x values, and range is all possible y values or all possible output values. So that's how you can remember, and just so that you do not get those two vocabulary mixed up. Okay, so let's try to use what we learned to figure out what the domain and range was for the drone example. Okay, so if you have this domain, what domain is all possible input values. Remember, how far does the graph extend on the x-axis is what the domain is. So how far does it extend? It extends from 0 to 7, doesn't it? And they come with units. In this case, it's 0 seconds to 7 seconds. That's when we have the graph. So the domain is between 0 to 7 seconds. What about range? Range is how far does the graph extend on the y-axis? So we're really talking about the y values, the possible y values. Okay, so we're talking about the y values. The graph extends from 0. That's how far the graph goes. It starts at 0, and the maximum value the graph reaches is 4. So we're going to say it goes from 0 to 4 meters. Okay, so let's try the domain and range problem with on Desmos. You're going to go on to card 7 to 15 right now. Okay, okay, so we're going to do this together, and I'm going to let you go on your own too. Okay, all right, so the first card on the domain and range section of the Desmos says, a mathematician says something is wrong with the shading of this graph. What do you think? Okay, so the domain is represented by this orange shading. So we're trying to demonstrate domain by this orange shading. Is this correct? No. So it starts, the domain, the graph starts at this point. Does it end at this point when x is, say, little over 5? No. What's going on? It extends beyond the graph, doesn't it? Okay, so you are going to write your answers. What do you think? If you don't understand what this is, then don't worry, just give it your best guess. Okay, what do you think? Okay, I'm not gonna answer that. I will let you answer that. Okay, all right, then we're gonna fix it. Mathematicians use this type of shading to represent the domain of a function. To exactly measure the domain of the function, we include all the x values that the graph crosses. Okay, drag the orange point to fix the shading for this graph. Describe the domain below. Okay, so that means we're going to try to move this to the left or to the right until we cover just the graph. Okay, there is no graph here, there's no graph here, there is no graph here, there is no graph here, there is no graph here, and right here we have the graph. That's the ending point of the graph. Okay, this is the starting point of the graph, and this is the ending point. And this orange region represents how far the graph extends on the x-axis, right? And what is the value? It extends from +1 to +4. So domain in this case for this graph is all x value, because this line is made up of billions and infinite number of tiny little dots representing x-y combination, input-output combination. That's what the graph is. So it's between, I am going to say it's between 1 and 4. I need you to adjust the graph first until this the graph extends exactly. Okay, and then I am going to submit. All right, then let's go on to the next. Now we're going to be talking about range. Okay, what is the range? Remember, that's all possible y values the function can output. Okay, so the output goes from, again, the graph extends, the y-axis, the graph extends from this point to maybe about this point. So we are going to move this to match up with that, and move this. Okay, we don't have graph here, we don't have graph here, and where do we have the graph? We have the graph right here. Okay, so then we're going to describe the range below. What is the range? Remember, range is really, we're talking about the y value, all possible y values. It extends from, so looking at the y-axis, it extends from 0, 0, 0, 0 to the y value here is little under 2, isn't it? Okay, so little under 2, so I am going to say it extends from 0 to little under 2, so that's about, okay, well, let's say 1.8. And if you want to, you can actually click on the dot and it will give you the number here. Okay, and it's going to be a lot more precise than what our eyes can see, and it's telling me it's 1.73, but I think it's really closer to 1.8. Okay, well, maybe you can put 1.7, it's up to you. Okay, and then I'm going to submit. Okay, so that we are saying that the range of this graph is between 0 and 1.8. Okay, we are interested in the y values here. Okay, let's go to the next graph, and the new graph is now you are moving this to